Okay, so let's take a look at this. So first of all, scatter plots. But when we talk about correlation, correlation is the R. Okay, if it's 100%, then that means R is going to be perfectly lined up. It's a perfectly straight line where every single point is on the line. That'd be 100%, right? The one we saw was 99%. So we had a pretty good line in our warm-up, okay? Do you still have that sheet? Yeah, let me show this. So the one we did, if you take a look at it, you know, not bad. These points are pretty well lined up, right? So our correlation was 0.99 or about 99%. That's pretty good, but it's not 100% because not all of the points are on the line, right? So you could also go and have a correlation of negative 0.99, which would be the same kind of line as this, except for it would be just going downhill, right? So anything close to 1 or close to negative 1 is a great correlation. So R equals 1 or R equals negative 1 is a very good correlation. Negative 1 is just going downhill, negative slope. Positive 1 is going uphill, okay? Now with most scatter plots, you'll never get it to be exactly 1, right? Because the point's going to be off. So if I take a look at this one here is pretty good. If I took a guess, I might say this might be about a 0.8 or a 0.9. It's just a guess. So my guess on this one might be, what do you guys think? What would you guess?
0.86.
I wouldn't go with 0.6, maybe that one. 0.8, maybe. Okay, 0.93. I like 0.93. That's just a guess. Okay, 0.93 means this is not bad. It might even be a 0.8. But now B, what do you think about B? I'd go with a negative 0.6 on that one. Because they're not... Negative 8.6? Okay.
Oh, for the first one.
Okay, 0.86. Okay, I'd go with 0.86. Yeah, I would go with 0.86, Austin. B, it's going downhill, so R is going to be negative for sure, but it's not as tight as some of the others, so what do you want to guess? Okay, negative 0.7. Negative 0.6 is not a bad guess. We know when we use the calculator, we'll get exactly what it is. Now, what about C?
0.
0 is pretty, I would go along with probably close to 0. So the whole idea of having no correlation would be a good factor. Okay, here's an example, okay, of no correlation. The taller you are, the smarter you are.
No.
Now, there are tall people that would agree with that, but there's just absolutely no correlation between height and intelligence. You agree with that? There's no correlation, right? However, in ages between 0 and 16, the older you are, the taller you are. There would be a positive correlation, right? That could make more sense. If I have age and height, that would have positive correlation. And this has no correlation, okay? So now, example 2. We have the distances. So we have basically, we have the months and we have the temperatures, okay? So if we want to do a scatter plot, let's put Akron down here, Akron, Ohio. Akron, and we'll put Wellington up here. I've got to go up as high as maybe 82, and I've got to go up as high as maybe 60. So if I go by 5s, I could probably get it 10, 20, 30, 40, 50, 60, 70. So I'm going by 5s, and I could probably do the same thing here. I could probably go 10, 20, 30, 40, 50, 60, and I'll just do my scatter plot, okay? 33. Let's do a scatter plot real quickly. 33 and about 67. This may be up here. 37 and 67. It's back up here somewhere. March would be 48 and about 65. 59 and 61, maybe about here. 70 and about 56, maybe down here, about right about there. 78 and 53, about there. 82 and 51. 51, about there. Where was I? 80 and a 73. Might be up here. Where was I? 61 and a 57, about there. 49 and a 60 is about there. And a 38 and a 64 is here. Okay, so scientifically, what are we doing? Opposite sides of the world. Northern hemisphere, southern hemisphere. When it's our summer, it's their winter. And when it's our winter, it's their summer, right? So that's why there's a correlation, and you can see that when they're hot, we're cold, and vice versa, right? Australia, like you think about Holly. For Holly, she went home, and it's summertime. Lucky Holly, right? For us, it's...
Does it ever get cold there?
Oh, yeah,
No.
yeah. Oh, yeah. In fact, the southern part of Australia is fairly close to Antarctica.
Oh.
Yeah, if you were way down the southern part of it. Australia, yeah. So now, again, what we want to do is if we were to draw the line of best fit, you know, the best we could do is draw in a line, and, you know, it looks like, well, maybe like that. And I'm not going to hit all of the lines. So if I could come up with an equation, and the best equation comes from the calculator. So again, the steps are here. And we'll go through it again. And I'll go through it with you. So step 1, we're going to go back to stat. We want to edit because we want to get rid of our wave numbers, right? So we're going to go up and highlight that, clear down, right? Go up and highlight your list, clear down arrow, okay? So everybody clear their lists. I want to make sure everybody can do this. Alyssa, you need to put that coloring away, please. Thank you. Okay? So make sure everybody's got a cleared list, and then we'll put in Akron for list 1. We'll let that be L1, and we'll let Wellington be list 2, okay? So I'll just start putting in numbers. I'll go 33, enter, 37, enter, 48, enter, 59, enter, 70, enter, 78, enter, 82, enter, 80, enter, 73, enter, 61, enter, 49, enter, and 38, enter. Okay, so I've just put in Akron, Ohio. And now let's put in Wellington, so that'll be list 2, all right? So I'll put in my list 2 numbers. I'll go 67, enter, 67, enter, 65, 61, 56, 53, 51, 52, 55, 57, 60, and 64. Okay, so what I've done is I've put all of my data into list 1 and list 2. Okay, so thumbs up if you're there. Who's with me? Okay, good. So wait a little bit longer for everybody to get the data in. Okay, give me thumbs up when you get all the data in. Okay. Okay. All right, Daniel, you're almost done, right? Vanessa, almost done, right? Okay. All right, so then what's the next thing? Well, we want to come up with an answer, right? So let's go back to stat so we can find our calculate button. Okay, so go back to stat because now we want to calculate an answer. So I go to stat. I'll go to calculate, right? I want to calculate my answer. I'll push. The one I want to find is my linear regression, right? So I want to go to 4 because I want to calculate a linear regression because it's a straight line, right? So I go to my linear regression. I push enter. Now I need to tell it which 2 lists to use. So go list 1, which is in second blue, and list 1's down by the number 1. I have to push comma to separate the list, comma. List 2, which is in blue, list 2, okay? So now I'm saying to the calculator, do a linear regression line in the form of ax plus b for list 1 and list 2. So push enter. Now the answer is in front of us. It tells us A is negative 0.317, B is 77.7. So the equation I'm going to use is going to be a y equals a negative 0.32x plus a 77.7. Okay, and I got that from my calculator, okay? There's my negative 0.32x plus 77.7. Now, how good is my data? So what's the correlation coefficient? It's the R. It is negative because the line does go down. So my correlation coefficient, R, is equal to negative 0.97. So it's saying really like 97% of the dots line up, okay? So 0.97 is a good correlation, all right? Thumbs up? Everybody got it? Okay, good. You guys ready to turn the page? Okay, let's do this one more time so that we can get good at this, okay? Same kind of problem, right? So let's do a scatter plot. Oh, I might go by 2s to go all the way to 21, so I'll go 2, 4, 6, 8, 10, 12, 14. I want to do it one more time so we get good at this. 22. Now I'm going to do a little squishy. You guys want to see a squishy? So this is squishy. So I'm compressing the bottom half of the graph because I want to start at, say, 350, okay? So I accordioned from 350 to 0. So all that's accordioned because I don't need that data, right? So I squished it. It's an accordion. And now I can put in the rest of these numbers. Now let's see, I have to go, what's my highest number? 580. So if I go, maybe if I go by 50s, that's going to be 400, 450. I can go bigger than that, can't I? I can go by 25s, I think. Let's see, 1, 2, 3, 4. There's 450. 1, 2, 3, 4. There's 550. Yeah, that'll work. I'll go by 25s. So this is 375. This will be then 400, 425, 450, 475, 500, 525, 550, 575, and then I'm all the way up to 600, which means everything should fit, okay? And again, I'm going to do scatter plot, okay? So I did it. I did my accordion. I squished all the numbers from 0 to 350, and then I went by 25s, okay? So scatter plot, 5 and 360. Okay, it's about there. Okay, we don't have to be perfect. 9 and 455 is about there, right? 12 and 460 is about there. Okay. 15 and 420 is maybe about there. Really, that's odd. Well, okay. Must have been good fat, not bad fat, huh? 12 and 530 puts us way up here. Must be real bad fat, huh? All right. 10 and 375. Right about there. 21 and 580. Oh, yeah. A lot of fat. 14 and 390. It's right about here, okay? So it's not a great correlation, but we know the more fat, it should have more calories, right? But there's good fat and bad fat. You guys know that, right? Good fat, olive oil, bad avocados, good fat, bad fat, palm oil, okay? Cheeseburger, I know. So there's definitely a correlation, right? But it's not a very good one. So let's go see if we can go back through this again and see if we can get the line of best fit. So if you need to use your steps as I go through it, got steps here. Okay. So step 1, I'm just going to hit clear. Step 1 is to go into stat. So let's go into stat. I'm going to edit because I want to change the data I have. I want to clear out the data I just did. Clear my list. Clear my list. Okay, you guys getting good at clearing your lists? Okay. Let's put our data in. List 1, I'll let R be fat as list 1, and calories can be list 2. So go 5, 9, 12, 15, 12, 10, 21, 14, okay? So go ahead and put list 1. Angel, just stretching?
Yeah.
Okay. List 2, so I cleared my list. Clear list. Now I'm going to enter data. That's what I just did. List 2, I'll go 360, 455, 460, 420, 530, 375, 580, 390. Okay? Now, I'm going to hit stat again because what I need is an answer. I need to calculate an answer, right? So I hit stat and I need to calculate. So I go over to calculate. And what I want to calculate is a linear regression line. So I'm going to go down to 4. So I'm going to get a linear reg line. So I push enter. Again, I have to tell it which 2 lists it's in. It's in list 1. I'm going to go list 1, comma, list 2, right? So I'll go list 1, comma, list 2, enter, right? And there's my answer. So my answer is y equals an 11.14x plus 309.76. Okay? So what's the correlation coefficient? For me, it's 0.68. So for me, the R, and hopefully you guys got the same correlation. And if you didn't, you know where to find it. You go back to stat, to tests. You're going to test your linear regression, which is F. And you go to calculate, and you can get it way down at the bottom. There's your R, 0.68. Okay, so R is about 0.68. Okay, now it's not a very good. In fact, if you look at it, it's not a great fit. So let's use this. So a 500 calorie sandwich. Find the amount of fat in a 500 calorie sandwich. So we should be able to put 500 in for what variable? Okay. Y. Because these are my Y's, my calories. So to do the 500 calorie, let's put the 500 here for Y, right? And we'll go, all right, 500 equals 11.14x plus 309.76. Because the calories are the Y values, I put the 500 in for Y. How do you solve? Well, subtract. Am I going too fast? Minus 309.76, which you're going to solve for x. Just going to solve for x. So I'm going to go 500 subtract 309.76, and I get a 190.24 equals 11.14x. Divide, right? Divide by 11.14, and again it's about 17. So it would be about 17 grams of fat in a sandwich with 500 calories. All right. So homework today. Not a lot of them because it's going to take some scatter plots. But page 146, 4, 6, 10, 28, 31.